Hi, this is Scott Gray from Team JR, here to speak about the new flybarless controller called the TAGS01 that JR is offering. It's a 3-axis gyro system with a lot of unique features that make it different from others on the market. Super easy to set up, very good flight characteristics for any kind of flying, and also works really well on electric, nitro, and gasoline helicopters. So I'm going to go over all the features today and also how to do a complete setup on a new helicopter and just show you how quick and easy it is to do. So here's what the TAGS01 comes with. It's got the main control unit here and 3-axis sensor. The really nice thing about the sensor unit is it's very small, and it also has a very heavy duty cable attached to it that goes to a very unique 180 degree turnable connector. So that's really nice for installing in a variety of different helicopters. You can move that in any direction you want. Of course, it's got a number of pieces of the special foam tape that's required to mount the sensor, the setup tool, and the manual itself is really detailed and easy to get through. And also the best part is you'll notice there's not a lot of pages, and that just shows you how easy it is to install and get this system up and running. So I'll be setting up the new E8 helicopter today, and I'll be using a new program on the XG8 transmitter. I'm going to pick model 5, call it a heli, and select and call it the E8 for now. That's good. This is a 140 degree setup on the swash plate. I'll leave all the swash mix numbers alone for now. The gyro channel is the gear channel, and we'll go in and pick our model 5. Now that we have a new transmitter program ready to go, the next step is to plug the swash plate servos and the tail rotor servo directly into the receiver. And you want to make sure you bypass the TAGS unit if you already installed it in the helicopter. This step you gotta just plug it directly into the receiver as if it was a flybar heli. So the swash plate servos are made up of 3 servos, and we have the elevator at the back, aileron channel on the right, and pitch channel on the left. Once we have those all plugged in, it's time to turn it on and make sure it all works. This part of the setup, we just want to get the swash plate moving as it should. We want pitch to be pitch, elevator and aileron should all be moving correctly. Right now they're not. As I move the pitch stick up and down, it's got some roll line interaction and elevator. This usually means one of the servos just needs to be reversed. So I just go directly into my transmitter program reversing and try a servo or two, see if it fixes it. That one didn't fix it, so we'll try the pitch channel and we're all set. Pitch is working normally up and down, elevator, fore and aft, and aileron left and right. Check that the tail servo works in the correct direction and the servo arm is centered and moves equally both ways. Now that everything's working in the proper directions, it's time to check the servo centering at mid-stick 0 pitch. The best way to do this is to zero out the pitch swash mix value in the transmitter settings. So in the swash mix function, you'll notice the default setting for the pitch is 60. I'm going to take that value, drop it down to 0. As I do that, the swash plate moves and finds its neutral position. Now we can take a closer look at each of the servo wheels and make sure that they're all square to the linkages. The aileron servo actually looks quite good in this case, but the elevator servo is a little off. The easiest way to fix that is to try flipping over the servo wheel, and sometimes you'll find a better spline for it to line up on the servo. Once we've done that, that looks a little better and it's quite vertical. Any more fine tuning you want to do, you go into your radio and use a little bit of sub trim. Anything less than about 25 points would be good, and it's safe to just adjust that so that it's just perfect geometry all around. Once you've got that right on the one servo, go ahead and do it to the other servos and we're ready to install the TAGS01. Now that everything's working in the right directions, the servo wheels are secure and sub trims are set, it's time to hook up the TAGS01 control unit. When mounting the gyro sensor to the heli, always use a supplied mounting tape. This is a thin double-sided foam tape. You don't want to use any kind of thick or soft foam tapes here. It's actually designed to be nearly solid mounted to the helicopter. And also, when you're putting the gyro on the helicopter, make sure to carefully align with the markings on the top of the sensor. That goes straight up and down the helicopter center line. The cable can exit either the rear or to the front, and make sure there's a bit of slack on the wire itself so it's not pulling on the unit. As you can see, the servos are still connected directly to the receiver. All we have to do now is move them to the respective slots in the TAGS controller. So we'll take the rudder, install it into the rudder slot, AUX1, which is our pitch servo, into the pitch slot, aileron into the aileron, and elevator into the elevator. Now from the TAGS unit, on the receiver input side, take the included cables and install them directly to the receiver. So we have aileron, elevator, rudder, pitch, which is auxiliary 1, and a gain channel which controls the gyro gain and also from stunt mode to hover mode from your transmitter. That goes to our gear channel on the receiver. Next up is the calibration. This is actually a really unique aspect of the TAGS01 control system. It's where the control unit itself here memorizes all the CCPM settings we did in the radio earlier. So what we need to do is actually isolate the pitch movement, aileron movement, and elevator movement for the controller to memorize. Now I can turn on the transmitter and the helicopter with the TAGS unit installed for the first time. So I'll power up the receiver. You notice the swash plate will do a series of random movements. That's normal because we haven't calibrated it yet. And now it's ready to enter the calibration mode. So just push and hold the calibrate button for a few seconds until the LEDs light up and flash. Now we're in the calibration menu, and everything will work normally as it did before. Now's a good time to actually check that we have zero pitch at mid-stick. So to do that accurately, I always go into swash mix, zero out the pitch value, just as we did earlier. Now the collective stick doesn't move the swash plate up and down, and we know that we're at exactly neutral. So I've got a pitch gauge on the blades. We can make sure it's at zero. That's important for the rest of the calibration process, to have blades on and zero pitch at mid-stick. So now we can move on to calibrating the elevator function. To calibrate the elevator, we need to isolate the elevator motion from other swash functions. So to do that, we go back into the swash plate menu and set the aileron to 0 and the pitch value to 0. Once we've done that, only the elevator function will work when we move the sticks. So elevator works, aileron doesn't do anything, and pitch doesn't do anything. That means we're ready to calibrate the elevator without any interaction. So to do this, we go into the calibrate menu for elevator. This is shown by a slow flashing light on the elevator label, and we can enter that by pushing the calibrate button. It starts flashing faster. Simply move the elevator fore and aft a number of times until the light becomes solid. That means the elevator's calibrated and we're ready to do the aileron. In calibrating the aileron, we need to isolate the aileron motion, just like we did in the last one for elevator. So we go back into swash menu, bring the aileron back to its default number. In this case it was 60%. And we zero out the pitch and elevator amounts so that only the aileron function works at this time. So aileron 60, elevator, and pitch equals 0. We're ready to calibrate the aileron channel. So we navigate to the aileron LED with the small pot here. And when it's going slow flash, that means we're ready to calibrate. Push the calibrate button shortly. Rapid flash means it's ready. Move the aileron stick. Once it's solid, calibration is complete for ailerons. And the final part of the calibration is the pitch function. Once again, we have to isolate the pitch motion from the other swash functions. We go back into the swash menu, zero out the aileron and elevator channels. That way only the pitch will move and we won't accidentally bump the other stick while we're calibrating. And we bring pitch up to 60%, which was our starting value. So the swash plate doesn't move with cyclic commands, but it does move with pitch. That means we're ready to calibrate the pitch function. So navigate with the pot to the pitch LED, which should slowly flash. And once we have that slowly flashing, we can push and hold the calibrate button briefly. Rapid flash means it's ready to calibrate. We go up and down with the stick. And now we have 3 LEDs showing all solid, and that means all the calibration is complete for elevator, aileron, and pitch. To save the calibration, turn the receiver off and then back on again. Basically reboot the system. Now the swash plate moves up and down as it initializes the gyro. When it's happening, we don't want to touch the transmitter or the helicopter while it's going through that initializing, especially at the field. On a windy day, make sure the helicopter is sitting still while it's turning on and initializing. So now we can go and put our swash mix values back to where they were for default, and everything should be operating. We have pitch, elevator, and aileron. The swash plate will move slightly differently than it used to, and that's because the gyro is now active and the TAGS unit is trying to do its thing. So that's normal. It won't move exactly with the stick, but all the functions should operate the correct direction. So now it's time to check the gyro compensation directions. To do this, we pick up the helicopter and take a look at the elevator axis first. You'll notice the swash plate is always trying to stay level. That means that one is correct. When we look at it head on and tilt the model, the aileron axis is backwards in this case because the swash plate is not trying to stay flat. That would cause a crash, so we got to make sure we fix that. To fix it, we go into the control box and flip the reversing switch for aileron. Take another look here, and the swash plate is trying to stay flat. So our elevator and aileron are now ready to go. Last, we just take a look at the tail rotor gyro compensation by swinging the tail back and forth, and just make sure that it's always trying to fight the rotation. If it's wrong, just flip the switch on the rudder reversing and it's all set. Now we set the mechanical limits of the swash plate. This is so the TAGS unit knows the maximum and minimum inputs it can apply without any mechanical binding. So to do this, I've gone to 0 pitch mid-stick and made sure my blades are on and at 0 pitch on a flat surface. And then we go and set a pitch gauge up to plus 12 degrees. So we're going to do the elevator axis first. We push full down elevator and we want positive 12 degrees here. I go on to the TAGS unit and adjust the pots for the elevator until I get positive 12 degrees at full down stick. Once I've done that, I'll set my pitch gauge for minus 12, and we'll do the same thing for full back stick on the elevator. So adjust the pot until I get minus 12 on the pitch gauge. Now our elevator is set. There's no binding on the swash plate or any of the linkages, and we get plus 12 and minus 12 with full deflection of elevator. For setting the aileron limits, we do the same thing as we did with the elevator. I've preset minus 12 degrees on the pitch gauge, and we check full deflection. You can hear a bit of binding at the swash plate, so it's clear we have to reduce that amount. So I've gone onto the pot on the aileron side and reduced that till we have minus 12 degrees of pitch and no binding at the swash plate or the servos. We do the same for positive 12 with left stick. So at full deflection here, we adjust the pot on the TAGS unit to make sure we have plus 12 degrees of roll input. When adjusting the rudder limits, I take a good look at the tail rotor and make sure there's no binding. If there's more room to go, we can just increase that on the right side and on the left, so that our tail rotor has maximum travel both ways. With the gyro setup finally complete, I can do my final check of collective pitch. Throughout the procedure, we've used the default values of swash mix, and it was 60% on the pitch function. That gives us well over 15 degrees, so I'm going to reduce that down to about 30%. And my goal is to get about plus and minus 12 collective range. So there's positive 12, and now we have negative 12, and the pitch range is all set and ready to go. Last, we'll just make a few final adjustments in the radio, and it's ready to fly. When doing final adjustments in the transmitter after the setup is complete on the TAGS unit, we're going to go into swash plate mixing and have a look at the aileron and elevator numbers. These actually adjust the maximum rotation rate of the aileron and elevator while you're in flight. So a low number would slow down the rate of roll, and a high number would increase the rate of roll. It's usually good to be between 30 and 50% on these numbers. I'm going to start with 40 on both aileron and elevator. When we go to actually fly the model, we can speed up the roll rate or slow down those rates with these numbers here. One of the other functions that you can use in the radio to adjust how it flies is the dual rate and exponential menu. You can go in there and change the rates for your aileron, elevator, and rudder, and add some exponential. I typically like to use about 30% expo on the cyclics, and for rudder, about 25 or more would be fine there as well. You can fine tune those while you fly it, just however you like it. Another great feature about the TAGS is that it has two pre-programmed flight modes. So these flight modes are hover and stunt, and they're already programmed into the unit. The hover mode is specifically designed for really stable hovering and really easy to take off and land. A lot of others on the market get a bit tippy near the ground, but the helicopter here with the TAGS is really easy to take off and land. Also good for scale helicopters and sport flying. The stunt mode that's included, you can access that with the gain channel on our radio, and we're going to get into how to set that up. What the stunt mode is really good for is 3D, aggressive 3D, and fast forward flight. It's quite amazing the difference between the hover and stunt modes, and it's really cool that it's all built in and ready to use. The preset hover and stunt modes are controlled by the gear channel on the receiver, which is gain 1 on the TAGS unit. So the gear channel is controlled by our gyro sensitivity program in the radio. Set that to the gear channel, and when we go in here we want to change it to tail lock. Tail lock simply means that it gives you either an N or a T option for each of the flight modes, normal, 1, 2, and hold. And we can select either a T or N there. N means it's going to tell the TAGS unit to go into hover mode, so it has really nice takeoffs, landings, and good hovering. And the T means go into stunt mode for full 3D and aerobatics. So I've already set that to N for normal, hovering mode, and T's for our stunt modes. There's a couple different ways to adjust the gain settings. The easiest way is to just use the tool and adjust the gain pots right on the unit. So aileron, elevator, and rudder each have their own gain setting. So just go ahead and fly the helicopter and adjust those up or down depending on if they need more or less. If you want to do any finer tuning, you can go into the gyro sensitivity menu, and next to each flight mode that we set up earlier, that number can adjust all 3 gains up or all 3 gains down together as a group. So you don't always have to go to the helicopter and adjust it manually. You can use the transmitter to go up and down. For an even more advanced gain setup, we can set the gains to be controlled for the rudder gyro and cyclic gyro separately from the transmitter. This way they're not all grouped together on one channel. To do this, I've just added a cable in the gain 2 input. I'm going to put in a free channel on my receiver, which is auxiliary 2. Go into the radio and device select, and under the auxiliary 2 channel, tell it you also want it to be a gyro. Once that's set, we can go back to the gyro settings, and we'll notice that we have another page here. The first page is as we set it before, But what's now different is the gear channel is only dedicated to changing the gyro gains of the rudder. All these numbers and values will only adjust the tail rotor. When we go to the next page, we have an auxiliary 2 now. This is going to control our elevator and aileron gains together as a group. I'm going to select and make sure it's set to tail lock, and I'm going to also make sure we've set that to N, T, T, and N for the stunt and hover modes. And now all these numbers here are going to adjust together the aileron and elevator. I can even do this in flight, and I recommend doing this. Just pick this value and start flying the heli. If it needs more gain, roll it up. If it needs less, roll it down, and find the exact place you need to be while you fly. Once that's set, just push enter, and you have the perfect gain setup for your helicopter really fast in one flight. If you'd like to have full control from the transmitter to operate the gains for aileron, elevator, and rudder separately, you can just add from the gain 3 input to another free channel on your receiver, another cable, set up another gyro channel, and you'll be given a third page. Now you'll have access to all three. Keep in mind that the gain pots will always be active, and you can still override any changes you do with the transmitter, and the transmitter will always add or subtract from what you have from the gain pot set here. Well, that concludes the setup procedure on this new helicopter. I went into a lot of detail on how to do it, but when you break it down, it's really only about a 5-step process. We set up the heli as if it had a flybar, installed the control unit and sensor, we did the calibration, set the mechanical limits and gyro directions, and we finally did the gain settings in the radio. After that, it's ready to fly. So overall, I'm really impressed with this gyro system and how it sets up and how it flies, using it in a lot of different helicopters. And compared to others on the market, it really outperforms them in all areas. For hover, takeoff, and landing performance, fast forward flight, and even extreme 3D. It really flies awesome out of the box. So I recommend you try one and see for yourself, and thanks for watching.